If you are interested in Linux CNC, watch this. Hi guys, wait a minute, I'm almost done. Maybe the wiring is right. What happens if I wire it wrong? Well, maybe I can manage. Now I just have to hope that it spins correctly. Okay, the spindle is under control. Next up are stepper motors. Stepper motors are also perfectly controllable. Yay, I did it. It took longer than expected, but I finally did it.
What are you so happy about? Made from moonshine you've been making for a while. I know exactly what I'm talking about. Let me drink that.
No, it's not. I don't make that kind of thing. This is proper whiskey. All right, let's drink together. I finally finished setting up a Linux CNC for my 5-axis machine.
You've been working on your Linux CNC setup for a while now, and it's finally done.
So today, we celebrate.
Okay, let's have a drink.
Cheers. Thank you. Thank you so much.
Hey, freak. You've done several LinuxCNC setups in the past, and you had a hard time with this one as well.
Yes, it is. Just because someone likes CNC machines doesn't mean they're knowledgeable about controls or programming. I think there are people who want to make their own cool CNC machine, but they will have a hard time because they don't know much about the controls. In fact, that's the case with me. By the way, Angel, are you interested in how I thought about choosing Linux CNC as a control program, selecting and setting up what I needed?
No, I'm not interested at all. I'm more interested in how this moonshine is made. It tastes just like Jim Beam. We could make a lot of this moonshine and sell it as Jim Beam and make a fortune.
What? If I told you that, you lose my plot. First of all, it's a crime to sell moonshine. Don't do it. Besides, if you're going to do it, you should make a more expensive fake whiskey.
Oh, freak. I knew the freak was a genius. I respect you. Let's do it.
Wait a minute. No, it's not. You're getting a little crazy. First of all, this is not moonshine, and we don't sell fake whiskey. This video is just a video to explain as clearly as possible, based on my experience, to anyone who is interested in Linux CNC, from the time I decided to start Linux CNC to the completion of my ideal setup. That way, it will help people who have the same hobby as me, even if only a little. So, if you don't tell me that you are interested in my machine and Linux CNC, I can start explaining it to everyone. So please stick to the script. If you don't, I won't let you drink anymore.
I get it. You're going to pretend to be a good guy and sell moonshine. I'm on it. Hey freak, your machine is awesome cool. I can't wait to hear your explanation of this machine and your Linux setup. Nothing like talking about your machine over a nice drink. Want to build your dream machine with Linux CNC while enjoying this delicious drink with Angel? Then hit that subscribe button.
I feel like something is wrong, but anyway, Angel insists on knowing, so I'll explain it to you. To make it easier for you to understand, I will break it down into 6 processes. If you can make it to number 4, you can actually operate the machine. The 5th and 6th steps are for further development. 1. Confirm the configuration of the machine to be manufactured. 2. Select CNC software. 3. Determine the configuration of the CNC unit. 4. Level 1 configuration by PNC-Conf. 5. Level 2 edit and use sample programs. 6. Level 3 proactively add new functions.
Okay, I am very excited.
1. Confirm the configuration of the machine to be manufactured. First of all, let's confirm the configuration of the machine to be built. As you may know, the machine I am building has 5 axes. Each axis uses a closed-loop stepper motor.
Why use closed-loop stepper motors? Why not use servo motors or regular stepper motors?
Simply put, it is a relatively inexpensive and easy-to-use motor that can compensate for the weak point of stepper motors, which is step-out. I have been building machines so far, and I think this is the best I can do at the DIY level.
It's great that it's inexpensive, has the performance you need, and is easy to use.
One feature of this machine is that it is designed to use 2 stepper motors on the y-axis. In addition, the coolant pump will also use a stepper motor, so a total of 7 stepper motors will be used.
Wow, you use a lot of motors.
That's right. Most people have a machine they want to build and think about what kind of controller they need to control it. Therefore, it is necessary to first clarify what kind of machine you are going to build and how much performance you need. In my case, I need to control 6 stepper motors other than the coolant stepper motor as a 5-axis machine.
Well, the first step is to decide on the machine you want to build.
2. Select CNC software. LinuxCNC is not the only program that controls CNC machines. There are several others. Usually, GRBL and Mach 4 are the choices. GRBL is easy to use and suitable for beginners, but it is standardized for 3 axes. However, with the extended version, more than 4 axes can be controlled. But my machine uses a total of 7 stepper motors, so GRBL is not suitable for my machine. It is inferior to LinuxCNC in performance and expandability. In conclusion, GRBL is not sufficient for my machine. Next, Mach 4 runs on Windows and supports 5 axes, but it is a paid software, so I would like to use it for free if possible. LinuxCNC has high real-time performance, supports up to 9 axes, is free to use, and is very flexible. As a result, I decided to use LinuxCNC. Please check out the chart my best friend ChatGPT has made to compare. He lies sometimes, but it should be true.
LinuxCNC is free to use and high performance is great. It's like cheap and tasty alcohol, but I doubt that it's all good things. Are there any disadvantages? Maybe it's an illegal program or something.
You are rude. It's not like the illegal moonshine you are trying to sell. You're only thinking of yourself.
Hey freak, can you please stop putting out such malicious images? I've never thought such a bad thing.
The people involved in the development of LinuxCNC are wonderful people who are willing to let ordinary people like us use their knowledge. The disadvantages are that LinuxCNC basically does not run on Windows, and the various settings are difficult for beginners to understand. Because of its high performance and flexibility, the settings can be complicated. However, there is a way to solve this problem, which I will explain later. 3. Determine the configuration of the CNC unit. Once you decide to use LinuxCNC, you need to prepare a computer with Linux OS installed. This is because LinuxCNC runs on Linux OS. Furthermore, CNC programs like LinuxCNC require real-time performance. To maintain real-time performance, not every computer is suitable. The type of CPU and its compatibility with real-time kernels are critical factors. Linux is an open-source operating system with many different distributions. LinuxCNC primarily recommends Debian-based distributions. If you use other distributions, additional configuration may be required.
Sounds like it's going to be difficult. I have no idea about real-time or Linux distributions. To be frank, I don't care about computers or operating systems. Just tell me the easiest, cheapest, and least problematic way to do it.
That's right. I know exactly how you feel. This is a pattern that, at our level, the more we look into it, the more we don't understand it. So I will simply respond to Angel's request. The easiest and simplest way is to use Raspberry Pi. I explained how to set it up in another video, so watch that.
Raspberry Pi is an onboard PC, right?
Yes, it is. You can get an ISO image for Raspberry Pi from the official LinuxCNC website. You can run LinuxCNC without thinking anything. Even if a problem occurs, it is easy to find a solution.
This means that there are many people using the same ISO image with the same Raspberry Pi. So if problems occur, there is a high possibility that the solution can be found on the forum.
That's right. You are very bright today.
Well, you know, you'll be smarter after a glass of this delicious whiskey.
I think you have found that you can easily use LinuxCNC with Raspberry Pi, but you can't control the CNC machine with Raspberry Pi alone. It doesn't have enough real-time control, and it doesn't have enough I/O pins.
What do you mean? I don't understand.
In short, the Raspberry Pi is not a high-performance PC and needs a board to extend the missing functionality. There are so many different types from so many different companies that it is very difficult to make a serious choice.
I don't know how hard it is for you to tell me what to do. So you can't tell me your conclusions quickly. Which one should we choose?
In this regard, it is hard to say which expansion board is absolutely recommended, but for beginners, I strongly recommend the Mesa board, which has been used in LinuxCNC for a long time. Since they have been used for a long time, there is a lot of information on them, so it is easy to solve any problems that may occur. And most importantly, it can be configured using PNC-Conf. This is a software application for setting up a Mesa board that can be configured using a GUI, making it easy for beginners to understand. Using a board supported by PNC-Conf is the easiest and the least likely to cause problems.
I see. So it's easy to set up with the boards that can be selected in PNC-Conf. But what's the difference between the various boards?
When using a Raspberry Pi, you cannot simply choose any board. It is essential to select a board that is compatible with the Raspberry Pi. For example, the 7C81 is an SPI-connected board specifically designed as an expansion board for the Raspberry Pi. On the other hand, boards like the 7i76C, 7i92, 7i96/7i96S, and 7i98 use Ethernet connections, allowing you to control CNC machines over a network. However, boards like the 5i25, which require a PCI interface, are not compatible with the Raspberry Pi. Choosing the right board based on performance and use case is crucial. By making the correct choice, you can effectively build and operate a CNC machine with a Raspberry Pi. I think you should actually visit the Mesa site to see these differences.
Which board did you decide to use?
I decided to use 7C81. This is for Raspberry Pi only and cheap.
Anyway, it is best for beginners to use a method that causes as few problems as possible.
4. Level 1 configuration by PNConf. From here, you can actually set up the machine to work. As I explained earlier, PNC-Conf is software that supports setup specifically for Mesa boards. It makes it very easy to set up the hardware. If you are interested, you can watch the setup video I made for Mesa 7C81. The first step is to create a configuration that works without fail. This is the setting made by PNC-Conf. PNC-Conf can set up to 4 axes, so if your machine has less than 4 axes, PNC-Conf may be all you need. The most important thing to understand at this point is that PNConf makes it easy to create a configuration that allows the Mesa board to output signals to control the hardware.
But the machine Freak is building has 5 axes, right? So, it's not possible to set up 5 axes with just a PNC-Conf, is it? What are you going to do?
That's right. I'll explain that in the next section. 5. Level 2. Edit and use sample programs. PNC-Conf generates INI and HAL files that can actually control the hardware with a simple setup. It is very attractive to be able to run a motor as soon as the motor driver is wired. However, PNC-Conf is limited in what you can configure and does not allow for complex settings. One of them is that it does not support 5 axes. To begin with, LinuxCNC is very expandable, and we can add various functions.
What exactly are the various functions?
To confirm this, it is easy to understand by looking at the sample programs. If you start LinuxCNC normally, you can select many sample programs.
There are so many of them. I have no idea what's what.
It's fun to try things out. Some of the functions I don't understand, but when I look into them, they can be quite useful. I would like to use a Vismix sample program.
That's different from the original interface you created with PNC-Conf.
That's right. Various functions have been added. Vismec is a virtual machine simulation function, and this is a sample simulation.
This function sounds interesting.
I agree. There is also TCP functionality that can be switched. Furthermore, there is an additional feature called NGC-GUI. I didn't know much about it, but I looked it up and found it to be very useful. This is an interesting feature that allows GUI-based macro programs to be called. I intend to make a video about NGC-GUI when my machine is completed.
This is awesome cool. The setup I just made with PCN-Conf is too simple and boring. Let's use this instead of that.
I agree, but it's not that easy.
Why not? It's already working fine. What's the problem?
This simple configuration itself is working fine, but it is not set up to use the 7C81 board I described earlier. It is also configured to use servo motors, not stepper motors. Also, there are some special settings included in order for LinuxCNC to run correctly without any hardware.
Again, this is getting harder to talk about. In short, you mean it looks good, but it's useless.
Yes, that's right. Same with you. It's about looking good but not being available.
I'm not sure if I'm being complimented or put down.
In other words, just as I am smart enough to compensate for your stupidity, this sample configuration needs to be corrected as well.
Can't you give me another better example? And how am I supposed to modify these incomprehensible INI and HAL files? I really hate this kind of thing.
It is not an easy task, but it can be done if you try hard enough. You just have to compare the configuration with the one created with PNC-Conf to see what's different and modify it.
So the configuration you made in PNC-Conf is complete for 7C81. So if I compare it to this and modify it, you can make a cool configuration.
Anyway, we compare the settings created with PNC-Conf with the sample configuration and modify one or the other. At this point, the important thing is to use proper code editor and Git management to make the modifications efficiently.
What is that, code editor and Git?
There's another video about that too, so watch this one for more details. This modification process will show you a lot of errors. The important thing is to modify it little by little to make sure it works, not to modify it a lot at once. If the cause of the error is not limited, you will have a very difficult time. If the cause of the problem is limited, it is easier to find a solution to the cause.
Please be a little more specific. There's so much I don't know. I don't know where to start.
Yes, I get it. What you don't know, you need to research. First, if you fundamentally don't understand these codes, check the manual on the official website. The INI file is explained here. HAL files are explained here. The manual has a lot of detailed information. When you start modifying the files and trying to see if they work, you immediately get an error like this. It says a lot of complicated stuff, but it's easy to understand if you look at the bottom of the page. It tells me where the problem is. When LinuxCNC starts and you want to check the status of the HAL pins, use Show HAL configuration to check the pins, parameters, and signals. Simply put, it looks like this.
So what about your configuration?
It now looks like this. I combined a PNC conf settings with the Vismic sample configurations and added a few more settings. Pretty cool, right?
It looks good. It can control the motor properly, can't you?
Of course, but it was pretty hard. I made a VCP switch that forces the switch to work without a home switch since the machine is still in production. The Vismic setup is perfect. I had a hell of a time setting this up, too. As a result, I was able to create a satisfactory setup.
You made many other versions of a model besides this 3D model.
I also made the video about Vismic, so if you are interested, please watch it. Now that I think about it, I think I created quite many videos about LinuxCNC. 6. Level 3. Proactively add new functions. From here, I'm talking about adding new features more aggressively. I have not reached this level yet, but LinuxCNC is open source software. Anyone with knowledge can participate in its development. You can also make LinuxCNC more useful by adding functions that are not available now. I would also like to learn programming. This is where the appeal of LinuxCNC really starts to expand. For example, you can use Python to add automatic measurement and tool change functions to LinuxCNC. Also, if you learn C or C++, you can create HAL modules and drivers. This allows you to work smoothly with special hardware and sensors. In fact, the LinuxCNC development community continues to evolve as users from all over the world bring new ideas and code and help each other. Finally, when starting something new, it may seem difficult at first, but it is definitely worth the challenge.
Hey Freak, by the way, what was that story about making a lot of money selling moonshine?
There was no such plan from the beginning. It was just an assumption you made on your own. This is the end of this video, but the project for the 5-axis CNC machine is still going on. In next video, I will again go back to building the machine. If you are interested in this project, I suggest you subscribe to my channel so you don't miss any videos. If you empathize with my project, why don't you become a member and support this channel? There are a few benefits, but as long as you are a member, your name will appear at the end of the videos as a patron. In other words, you can be a part of this project. So, please look forward to the next video.